Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. 2018 question, yet another one on that paper on sequence and series. This time it's question 7 of paper 2, and it was unusual to get a sequence and series question on paper 2. However, a section of a garden railing is shown below. This section consists of 9 cylindrical bars labelled A to I with a solid sphere attached to the centre of the top of each bar. The volume of each sphere from B to E is 1.75 times the volume of the previous sphere. The radius of sphere A is 3 centimetres. So the radius of that one is 3. Okay. Find the sum of the volumes of the spheres A, B, C, D, E. Give your answer correct to the nearest centimetres cubed. Okay, so the first thing to note here is that the volume, one is a ratio of the other, okay? So in other words, if you multiply B, if you multiply the volume of A by 1.75, you get the volume of B. If you multiply the volume of that by 1.75, you get the volume of C, and so on and so forth. So this makes us a geometric sequence. Okay, so that's the first thing. So when you're in your log tables, you are down here in the second half. Okay, and you've two formulas. Well, you've three. You've one to find a general term, Tn, but you've two for the sum of. Okay, so Sn, it tells you up here, is the sum of the first n terms. We use that one if we're summing a finite number of terms. We use sum to infinity if it's an infinite number of terms. Okay, so we are summing in this one, so I could, of course, use that sum formula. So there's two ways of doing this, and if it's okay with you, I'm going to do it both ways. So I'm going to get the volume of A first. What am I finding? The volume of the spheres. Okay, so my log tables, let's go back to find the volume of spheres. Where are my sphere, volume 4/3 pi r cubed. Okay, so V is equal to 4/3 pi r cubed. So for A, it's 4/3 pi r cubed, and that is 3 3s are 9 divided by 3 cubed. 36 pi is my volume of A. B then, of course, I know it's 1.75 times the volume of A. So 36 pi multiplied by 1.75, and that's 63 pi. C then is 1.75 times 63 pi. So multiply that one by 1.75, and I have 441 over 4 pi. And D is equal to that multiplied by 1.75, and I'm getting 3087 over 16 pi, and E is that multiplied by 1.75. 1.75 times 3087 over 16 pi, and it's given to me as a decimal this time, 1060.73. Okay, and of course I sum them all up together because it says find the sum of the volumes. So 36 pi plus 63 pi plus 441 over 4 pi plus 3087 over 16 pi plus 1060.73. And I'm getting 2324.24. What are the centimeters cubed for the total volume? I'll give your answer correct to the nearest centimeters, 2324 centimeters cubed. Okay. so that's that one done. Or, of course, I could have used the Dsn formula, which is, let me go back to sequence and series page. A times 1 minus r to the power of n over 1 minus r. Okay, so my first term here in this sequence would have been, because I'm summing volumes, 36 pi, and my common ratio is of course 1.75. Okay, so let's put that in. That is 36 pi times 1 minus 1.75. I am summing A to E, so I have 5 spheres that I'm doing. So that's why n takes on the value 5, okay? And strictly speaking, I would have S5 over here, which is the sum of the first 5 spheres. Okay, so hit the fraction button, 36 pi bracket 1 minus 1.75 to the power of 5. That's your bracket over 1 minus 1.75. Okay, and I'm getting 2324.24 for that, which rounded 2324 centimeters cubed. Okay, so the formula was much faster if you saw it. You still had to work out volume A, of course, to give you your first term, but your common difference or your common ratio, 1.75, they gave it to you. So that was part A for that question, and that was 10 marks for that one. So the surface area then of sphere E can be taken to be 503 centimeters squared. So the surface area, okay, of a sphere. So the trick here when they give you something like that, so surface area of a sphere, 4 pi r squared, okay. So what they're saying to me is 4 pi r squared, the surface area is equal to 503, okay? Let the formula equal to the amount. The height of the railing at E is 1.2, okay, I can see that in the thing. Find the height of the bar E, okay? So I presume that's what they want. Okay, so if I find the radius of this, and I multiply that by 2 to find the diameter, and I subtract it off the 1.2, then I should find the height of that bar, okay? And why I say that is because they've given me the surface area being equal to 5/3, so the only unknown in that formula is the radius, okay? So let's divide across by 4 pi. So they cancel, so that I have r squared equal to 503 over 4 pi. Do you know what? I won't even work it out because I know that r, the radius, is the square root of 503 over 4 pi. And if I do it all in one go, then I have no rounding error. So 503 on the top, 4 pi, and I'm getting 6.326 or 6.33 to 2 decimal places for that radius. Okay, so therefore, if I could just pop out here, if you don't mind, the length of that bar, the height of the bar, is that 1.2 meters minus my radius, of course, is in centimeters. So let's convert 1.2 meters to centimeters. That's 120 centimeters, 100 centimeter in a meter. So 120 minus 2 times 6.33. And that's what? 120 minus 2 times my answer. And I'm getting 107.35 for that. Correct to 1 decimal place. 107. Sorry. 107.346547. So correct to 1 decimal place, 107.3 centimeters. Okay, or 1.073 meters if you left it in meters, whichever you want, because of course you could have converted this to meters to 0.0633 meters and subtracted it from 1.2. That would be perfectly fine too. Okay, the radius of each bar is 1 centimeter. Okay, so the radius of the bar. Okay, the volume of bar A is 71.3 pi centimeters cubed. The volume of bar A. Okay, so this is a cylinder. So volume pi r squared h. So I would say pi r squared h is equal to 71.3 pi. Okay, the radius of each bar is 1 centimeter. The heights of the bar A, B, C, D, and E form an arithmetic sequence. Okay, so in an arithmetic sequence, we're adding or subtracting the same value every time. And that's how we move from term to term in the sequence. Okay, so we know that for this bar, our radius is 1, 71.3 pi. So that's, let's divide across, that's pi h being equal to 71.3 pi. The pi's cancel. So I'm working out that the height of, which bar is this? So the height of bar A is 71.3. Okay. The height of bar E, didn't we just work that one out? 107.3. Okay. And then bar E, B, C, D, we don't know any more information about their particular heights. We just know more information about the volume of the spheres on top of them. So we have no choice but to use the fact that it's an arithmetic sequence, okay? So if he's, what is he, 71? If he's 71 and he's 107, then if I get the difference between them, then can't I just divide across to get me my common difference, okay? Because I have 1, 2, 3, 4 different, I suppose, jumps from sequence to sequence in this. Okay, so I am saying if I take 107.3 and I subtract from that 71.3, I get 36. Okay, and I have 4 jumps from that, so there is 9 centimeters between each bar. Okay, so in other words, if bar A is 71.3 that we have here, then 71.3 plus 9, he's 80.3, he's going to be 89.3. He's going to be 98.3, and let's just add on the last 9, and yeah, we're up to 107.3. Okay, so that's how you worked out the heights of all of those bars. Okay, and there was 10 marks for that. Okay, and then there was 2 more parts to this question, a part C and a part D. Right, part C. There is a wall on each side of the section of railing as shown in the diagram below, which is not drawn to scale. The distance from wall to wall is 1.5 meters. Okay, so 1.5 meters from wall to wall. The distance from the wall to the bar A is 20 centimeters. Okay, that's okay. And from the last rail to the wall is 20 centimeters. And each of these is a radius of 1. Okay, or a width of 2. Okay, because if the radius is 1, then the diameter is 2. So all of these is a width of 2. Okay. The gap between each bar is identical. Find the size of the gap. Okay. Is this as simple as 20 plus 1, 2, 3, 4, 5, 6, 7, 8, 9 twos plus 20 on the other side? So 20 plus 18 plus 20, 20, 40, 58. Okay, and then 1.5 meters, which is 150 centimeters, minus the 58 centimeters is 90 something, isn't it? 192, is it? 92 centimeters. Okay, so I have 92 centimeters unaccounted for. I have 1, 2, 3, 4, 5, 6, 7, 8 gaps. 92 divided by 8 is 11.5 centimeters. Okay, that's the answer. That, strangely enough, was worth 15 marks. Okay, and I would imagine that's because the last part in this was actually really difficult question. So this part is only worth 5 marks. The sphere on bar A and the sphere on bar B are to be joined by a straight rod as shown in the diagram below, which again is not drawn to scale. Find the length of the shortest rod that will join sphere A to sphere V. Give your answer in centimeters, correct to 1 decimal point. Okay. So you can see that I need the radius of both of them. Okay, for sure. And then I need the distances between their centers. For sure. Okay. Right, and then I need the height from center to center. Okay, and then it looks like I have some sort of a triangle, some sort of a Pythagoras Theorem jobby going on. Would you agree? So that I can get that length of a side as long as I have x and y. Okay, so let's try doing that. Okay, so let me clear off this for a minute. Okay, so I know that the gap between these two we have just worked out to be 11.5, isn't that correct? Yes. And the radius of the bar was 1 and 1. Okay, so I would say the bottom of my triangle then is 11.5, 12.5, 13.5. Okay, so that's the bottom, that's my y. Now let's have a look and see if we can work out the height up. Okay. Let's go back and see what we have here. The heights of the bars form an arithmetic sequence. So we have 9 centimeters here between the different bars. Okay. So I have a 9 centimeters here. Okay, I then need some radiuses. So didn't we work out what the volume of that ball was? So we got 63 pi. Okay, so the volume of that ball was 63 pi. So you can see the volume is 4/3 pi r cubed, and that's equal to 63 pi. So 4/3 pi r cubed is equal to 63 pi. So what I'm doing here is I'm trying to find the radius of that sphere so that I can work out this piece here. So 63 divided by 4/3. So 189 over 4. And if I cube root that, I'm getting my radius to be equal to 3.62. Okay. Okay, so why I'm pausing here at the moment is, I'll tell you why I'm pausing, okay? And this happens to me quite a bit in questions. When I look at 9, I'm trying to figure out, is the distance from here to here 9? Which I think it is, okay? I think that's the piece that's 9, okay? Or I'm wondering, no, it's not, I'm wrong. Okay, because I can see it now in the diagram. Okay, so it's the distance in the bars, okay? So that's 9. Can you see that? Okay, so it's the distance from this bar here to the start of this bar is 9. Okay, so I need to add on this 3.62 that's up there, but I need to subtract off the 9, the radius of the small one. Okay, because that's not included in my 9, because my triangle only starts here. Okay, so what I'm getting is that this side x is that 9, but I need to subtract off the radius of A, and I need to add on the radius of B. So the radius of A was 3, I think. Why do I think that was 3? Yeah, so the radius of A was 3. And I need to add on the 3.62. Okay, so for that I am getting 9.62. Okay, so that's my triangle. And then I use Pythagoras Theorem. C squared is equal to A squared plus B squared, which is equal to the square root of a 13.5 squared plus 9.62 squared. The square root of 13.5 squared plus 9.62 squared. 16.576 is what I am getting for the length of that rod. But remember, that rod is really just there. Okay, can you see it? What I have worked out is from the center to the center, the whole length of that side. So I need to again subtract off the radius from here and the radius from here. Okay, so therefore the length of the rod is 16.576 minus 3 minus 3.62. So I am getting the length of my rod to be 9.96 centimeters, I presume. Okay, so correct to 1 decimal place, 10 centimeters. Okay, so that was quite difficult, which is why I imagine part C ended up being 15 marks and this ended up being 5 marks. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.